back on the wall there, we have lots of things to do tomorrow, even though we're not gonna be here at school, or you gonna be. 10 topics, angles 1, angles 2, angles 3. Also, we are moving towards, next week, next Thursday is our knowledge check goal. It's gonna be out of 210 topics. Okay, so if you take care of your 10 topics every week, then you should be pretty good. If you wanna get a higher score than last time, then do a little bit extra topics. Unless last time you got 100%, in which case you really can't make it any higher than that. So go spend your time on some other class. All right, let's talk about the unit circle. Actually, I'm going to give it a better name. The 1 unit circle. You will never guess why it is called the 1 unit circle. Anybody? 1 unit radius. Okay, well you did get that. So we're going to draw a circle here, try to make it perfect. Mine was doing pretty good until I got to the very end there. Alright, so there's the center, and we're going to go out over here, and this is going to be 1 unit. We're going to utilize this circle to sort of create some different angles and some values, and then this 1 unit circle, Taylor, you can close that MacBook, thanks, is going to be super helpful for finding special angles and finding sines and cosines and all kinds of really neat stuff. So, enough talk. Let's just go ahead. We've got to build it first here. So, I'm going to talk coordinates here real quick, class. So, what is the coordinates of this point right here? That point right there. 1, 0. Now we're cooking. Let's go all the way over here to the other side. -1, 0. That's a parenthesis. Okay. By the way, we're in the habit of writing things in radians now rather than degrees, right? Let's do this in radians so you can handle degrees, no problem. If this is 0 radians, I'll put a 0 right here. How many radians is it all the way to that one? Anybody remember off the top of their head? Pi. Let's go and find a coordinate right up here. Someone other than, I think, Preston and Robert, they answered, or Charles, you answered one of them. It's fine, all 3 of you are out. So it's a circle of radius 1. So what is this point right up here? Just ignore the men in the doorway.
Sorry.
You're fine.
Yeah, just center where that thing is.
That's the that's the angle of rotation. But what is this coordinate up here going to be? So you answered the question I was going to ask next. All right. What's its x coordinate, class? 0. Yeah. What's its y coordinate? 1. It's 1 unit up. This is the easy part, right? Okay. I'm tricking you here. You think it's going to be too difficult. All the way around here, we know that that's 3 pi over 2. I guess I'll just put 3 pi over 2. That's pi. That's pi over 2. Okay, Dominic, what is this coordinate right here? Yeah, there we go. 0, -1. Okay, now we're cooking. So, for this 1 unit circle, we shall go with the 45s. So the 45 degree right there. That's pi over, anybody remember what 45 degrees is? 4. Pi over 4. Now, I'm expecting a wrong answer on this one. Okay? Your first guess on what that coordinate is going to be, just shout out what you might think. Just guessing.
0, 0.5.
You're close. Okay, maybe like 0.5, 0.5, I think that's kind of what you're getting at, right? Like a half and a half, right? Yeah, up to the right a half and then up a half, okay? But it's not, okay? Just, it isn't. We're gonna have to do a little side problem to figure out what that is, okay? So, little side problem over here. 45 degrees, I'm putting 45 since we're all pretty familiar with 45, okay? And, hey, it's a 45, 45, 90 triangle, how about that? And the hypotenuse has a length of 1, okay? Now, reach back a few weeks ago to special right triangles. Let's figure out what this side and this side are. You remember how we did all that? I forget, I think there's a pattern though. It went x, x, x root 2, right? So we knew that whatever we had here, we had to multiply it by the square root of 2 to get over there, right? So what if I have this number right here? How am I going to figure out mystery side? Say it again? Divide by root 2, yeah. So it's going to be 1 divided by root 2. Which we all hate because it's radical part of the basement, so we're going to multiply by root 2 over root 2. So we end up with the square root of 2 over 2. That's what this side is, and whatever this side is also what this side is, root 2 over 2. Therefore, we now know that the x coordinate, how far this kicks out, is root 2 over 2, and how high it kicks up is root 2 over 2. Now, I'll share with you a secret that is known to pre-calculus students everywhere. Let's take that calculator real quick and figure out what is root 2 over 2 as a decimal, okay? Because we're going to see this a whole lot, and if we can just kind of make that connection whenever we see this decimal, then we'll be like, ah, that's root 2 over 2. So, so it's approximately 0.707. Okay, so just have that in your mind, 0.707. Whenever you see that, 0.77, what's the next, like, 1 after that or something like that? Or 0.771. Whenever you see that, okay, yeah, that's root 2 over 2. Okay, just, you can pretty much do that. Alright, there we go. We've got this one filled out. Let's go over here. So it's not 0.5, right? It's 0.7, so that's kind of an interesting phenomenon. I'm going to go over here. I think this one was 3 pi over 4, right? Something like that. And maybe I'll try to make it look kind of matched up with that one. So 3 pi over 4. There's some interesting relationships now. I know that this was a 45 degrees, and I know therefore this one's a 45 degree, right? And so, and that this hypotenuse was 1. So really, I just have the same exact triangle, where it's 1 here and a 45. It's the same triangle as I had over there, even though mine doesn't look exactly the same. But this triangle, they're reflections. It's a mirror image of each other. Okay? So therefore, since this triangle on the right kicked out by root 2 over 2, how far is this one going to kick to the left? Yeah, negative root 2 over 2. So it's negative root 2 over 2, comma, and we should see that it's the same height. So the height is still root 2 over 2. And that's how we get this coordinate right here on the unit circle related to the 3 pi over 4. We'll then go down here to this quadrant, the third quadrant. Wrapping around 5 pi over 4. And it's the same exact thing. It's that 45 degree reference angle. Right? Use the vocabulary from before. Right? So it's literally the same triangle, only now it looks like this. 45, 1. So clearly, the left is root 2 over root 2, and this vertical is root 2 over 2. So this coordinate is negative root 2 over 2. And the y value, anybody want to make a guess? Negative root 2 over 2. Trey, ask me a question. You look thoughtful. Any questions on that? Does it make sense that it looks like the reflection? Well, in that case. Good. And then let's do the same thing here. 1, 3, 5, this would be a 7 pi over 4. And we've got a coordinate right there. This would be, it's going to kick over the same amount that this one kicked over, so root 2 over 2. And negative root 2 over 2. Okay. Hey, guess what, class? We now know where those numbers came from. Those numbers, the root 2 over 2, come from the 45, 45, 90 triangle. Namely, if you have a hypotenuse of 1, then your leg is going to be 1 over root 2, which when you rationalize the denominator, you get root 2 over 2. So, kind of a theme of this class is why, right? Like figuring out the why. Why does this all, you know? The how it works, how we actually, I mean, your homework is going to be like, let's be honest, homework's going to take you like 10 seconds, okay? But figuring out why it works and what's going on, that's kind of what this is all about. Okay. That's for all the 45s. Next up, the 30s and the 60s. So on mine, it's also just about the same amount of piece of paper. So we could draw it all on one circle, and that would be like a mega unit circle. But I found that it gets really busy if we do that. The paper gets a little crazy. So it'd be nice if we had some sort of like electronic tool to like space it all out, format it nice and proper, and make it so it's handwritten, you know. But I don't know if such a thing exists. And it's probably one of my worst triangles or circles I've ever drawn. It's really a bad triangle. Okay, still 1 unit. So here we go. Let's go ahead and go with the 30. So this is a pi over 3. I'm at 30 degrees there, this is fun. And I want to find this coordinate right here. Definitely looks, Dominic, you kind of get this point here. Do you think its x value is going to be bigger or its y value is going to be bigger? Looking at that, so this is the x value. Probably the x value, because the y value doesn't look very much, right? Let's go ahead and draw that triangle over here. 30, and there's the 60. And I'll put a 1 right there on the hypotenuse because this is the 1 unit circle. So over here I'll remember when I had the 30 and the 60. So across from the 30, you may remember this from the special right triangles, I'm going to write, I would normally write opposite, that's right, but with special right triangles I write x. And then on the hypotenuse I write 2x, and across from the 60 I write x root 3. So this is the hypotenuse. I want to know what is across from it. Or sorry, what's the 30 side? So I look over here and the relationship is that whatever's on the 30 side is half of the hypotenuse. So if this is a 1, then it's going to be 0.5. I'll write it as fractions since we're doing all fractions nowadays. 1/2. And then, in order to go from the 30 side to the 60 side, I just multiply it by the square root of 3. So 1/2 times the square root of 3, or as everybody calls it, square root of 3 over 2. That's what everybody calls it. So we kicked over, so this corresponds to our x coordinate. So square root of 3 over 2, we kick up 1/2. And since we're going to be seeing this a whole lot, what is, use your calculator, the square root of 3 over 2 as a decimal approximation? Give me 4 digits after the decimal place. Sarah, you got a number there? Uh-huh. 0.8660? We have confirmation? Yeah, okay. And also, class, since we're going to be using this so much, let's go ahead and use our calculators and find the decimal approximation to 1/2. Oh. So that's approximately 0.5. So this is about 0.86, so maybe almost 0.9, so like 86, well, if you're talking to your parents, it's almost a 90, right? You know, right? But that's 86. Anyway, 87, okay? So, but seriously though, Dominic, we were saying that this x value is definitely more than the y value, and looks like our numbers are backing up your estimation. So that's about 87 versus 50. So, okay, that's great. Let's go to the 60 degrees. So I messed that up, didn't I? It's not pi over 3. I'm doing this stuff. It's pi over 6. That one's pi over 3. 60 and 30. That's a good one to do, but let's walk around the circle first, because we'll draw these other ones with the 30 degrees and just kind of get them knocked out real quick. So I'm going to draw this other one that's 30 degree reference angle right here. That's 5 pi over 6. You'll see why, because it's that same exact triangle but reflected across here. So however far I kicked right on this side, I'm going to kick left over here. So that's going to be, instead of positive root 3 over 2, we're looking at negative root 3 over 2. And my y value, same, 1/2. I'll now go down to the third quadrant, and we've got 7 pi over 6. You can see it kicks over the same amount as that one, so that's negative root 3 over 2. And it kicks down the same amount that this one kicked up, so that's going to be negative 1/2. See how much faster this is now? And then fourth quadrant, that's going to be your 11 pi over 6. It kicks over to the right the same amount as this one did, so that's positive root 3 over 2. Kicks down as much as this one kicked up, so we've got negative 1/2. Now for that 60 degree one, okay? Pi over 3. That's really good. There we go. So I'm going to redraw that triangle over here on the side. So we've got a 60 degrees, 30 degrees. On my hypotenuse, I'm going to draw a 1. And I'll draw my right triangle over here, my 30, 60, 90. Call out to me, class. Across from the 30, what was the pattern? X on the hypotenuse. And across from 60, x root 3. So now, since this is my hypotenuse, across from the 30, I'm going to write 1/2. And then from going to the 30 side to the 60 side, I just take whatever's here and multiply it by root 3. So 1/2 times root 3. Well, that's just the same thing we saw before. Root 3 over 2. I guess we probably could have reasoned, it's the same triangle, it's just sort of, well, it's rotated and flipped and done some other stuff like that, but it's still that 30, 60, 90 right there, right? So the only difference is the short side is right here. So that's only going to go over 1/2. And the long side is the vertical, so that's your root 3 over 2. So this one goes over to the middle, so it goes over to 1/2, which actually kind of looks, kind of, sort of. And then up 0.866. So now I'll go over here to the second quadrant. So that was pi over 3, this one's going to be 2 pi over 3. And my coordinate, I'm going to kick to the left the same amount that this one kicked to the right. So this only is going to be negative. So negative 1/2. Vertically, it's the same. Up square root of 3 over 2. Third quadrant rather. 4 pi over 3. I kick over to the left the same as that one did, so negative 1/2. And I'm kicking down the same amount that one kicked up, so this is going to be negative square root of 3 over 2. And then fourth quadrant, kick over to the right, same as that one did, so 1/2. And then this kick down, negative 3 over 2. Wow, that's a whole lot of work. But we have now created those two circles combined are called the 1 unit circle, or sometimes just the unit circle. And you say, what are they good for? Well, it's good for giving you an exact answer, even more exact, that was kind of sad, than the calculator. Okay? His calculator is always going to give you decimal numbers. With the unit circle, we can get exact answers. And you might say, why would I need exact answers? Well, sometimes you need exact answers because exact answers with fractions and stuff like that are going to have things that will cancel out. The calculator cannot tell that they will cancel out. The calculator is just going to give approximations, and approximations get rounded, and rounded over rounded give you something that's not completely canceled out. But if you do have exact answers and things do cancel out, and you end up with perfect answers, which is what we want. That being said, remember how, I guess it wasn't yesterday because it was a work day, but it was 2 days ago, we kind of expanded our mind on sine, cosine, and tangent. Alright? Do you remember that? We said sine is no longer opposite over adjacent, right? We said sine of theta is now y over r. Okay? And cosine was x over r. And tangent was y over x. And we said what's more, now that we can actually find sine, cosine, and tangent of angles that are more than just, acute angles inside a triangle. So what I'm going to tell you now is we can, with this unit circle, we can find exact answers, all right, of these things. Let me show you what I mean. Let's just pick pi over 6, all right? We can now find out what is the cosine of pi over 6? And without a calculator, but with this unit circle, I can tell you in less than 2 seconds. Are you ready? Here we go. Cosine of pi over 6. Well, I know that the pi over 6 line is right here, okay? And I've already gone to the trouble of making a triangle, okay? It's already there. Someone's already done it for me. They tell me that the hypotenuse is 1, the x value is root 3 over 2, and the y value is 1/2. Are you all reading that right? So, the cosine of any angle is, based on this, the x value over the r value. Y'all with me? Now, what's the x value of this right here? Root 3 over 2. What's the r? 1, because it's a 1 unit circle. Well, that's easy. It's just root 3 over 2. Did I tell you need to associate cosine with x's in your mind? Yeah, that's why. Because now I can say, all right, hotshot, what's the cosine of 7 pi over 6? And you say, I don't need no stinking calculator. I know that cosine is the x over the r value. And 7 pi over 6, I've got that on my unit circle. 7 pi over 6 is right here. Someone already drew a triangle, and they knew that the radius was 1, the x value was negative root 3 over 2, and the y value was negative 1/2. And since cosine is x over r, the x value is negative root 3 over 2, and the r value is 1. It's just negative root 3 over 2. You want to find the cosine of an angle that's on the unit circle? Find that angle and look at the x value. Why don't you have to worry about the r value, class? Because it's 1. And anything over 1 is itself. Okay then, what about the signs? Oh, that's what he says. We'll see if he's right. The sine of, oh, I don't know. Let's go with that same one, pi over 6. Sine of pi over 6. We all know that the sine is what over what now, our new definition? No, new value is y over r. So y value, well, somebody already went and drew a triangle, us. Spent a whole class period doing it, oh my gosh. Okay, we already drew a triangle, okay, that had a hypotenuse of 1, a y value of 1/2, an x value of root 3 over 2. So the y value is 1/2, the r value is 1. Well, what's 1/2 divided by 1? So yeah, it looks like if you're looking for the sine of one of these angles, just go ahead to the unit circle and look for the y value of that, well, find that angle of rotation, and then look at the y value, boom, there's the sine. What about the sine of pi over 3? You can't speak. Trey? Sine of pi over 3. Not sure? It is right there. It's the y value of that. So what is that y value? Root 3 over 2, or square root 3 over 2. That's it. Grace, what's the sine of 11 pi over 6? Sine? The sine is the y. So 11 pi over 6 is right here. Negative 1/2. Y'all see how she got that? I never labeled that other one, did I? No. 4 pi over 3? It was 5 pi. Brianna, what would be the cosine of 5 pi over 6?
Negative root 3 over 2.
How did you get that?
It's the x value of the
Yeah. It's the x value on that angle of rotation. Bailey, what's the sine of 2 pi over 3? Yeah. You're trying to get a feel for it? Yeah, it's just the x value or the y value. That's really all I have to do. Now I think we should try this out. Let's you all have a calculator, right? Make sure that its mode is in radian mode. Okay? So hit the mode button, let's go to radian because we're talking all about radians. And let's type in sine 2 pi over 3. Enter. Preston, what do you get? You didn't do it. Ruth, what do you get? Alright, take your time.
It's 2 pi over 3.
Uh-huh.
1.866.
0.8660. Okay? Do a math enter on that. Everybody do a math enter on that. And laugh at your calculator. Because you are smarter than your calculator. Yeah, you are. 0.866. It's like 0.8. Alright, these calculators don't have a computer algebra system, so therefore they cannot turn well-known rational or irrational numbers into their square root fractional equivalents. It doesn't. No, you need a brain. Alright? Your brain knows that 0.860 is root 3 over 2, or even better, you just throw that calculator in the trash, alright, and you just get out an old sheet of paper and write your unit circle down, because your unit circle is going to give you root 3 over 2. Okay? Well, you probably have noticed by now that I have been shying away from tangent. Right? Why? It's not. It's just different, okay? Sines and cosines, boom, boom, it's just right there. Now, I didn't give you any from the pi over 4 stuff. I probably could have. But the tangent is the y over the x. So, I'm sorry, you're going to have to do just a little bit of one extra step if you're going to find the tangent. You cannot get the tangent in the same way the sine and cosine, Dominic, because the sine, you're literally just looking for the y, right? The cosine, you're looking for the x. But the tangent is going to be this over this. And unless you can do 1/2 divided by the square root of 3 over 2 in your head, you're going to have to just write that down. Does that make sense? You can handle that. I've been playing Mario Kart too much. It's got that 1,000-yard steer going on. So let's say tangent. We'll just go ahead and use this one right here, for example. So tangent of pi over 6. With a tangent, you're just going to have to bite the bullet and do the fraction work. It's the y over the x. So it's going to be the 1/2 over the square root of 3 over 2. Yeah. Now the thing is that we don't like fractions of fractions. So we're going to have to write the numerator, but then instead of saying divided by the denominator, we're going to say times, and then go the reciprocal of the denominator, so times 2 over root 3. Y'all remember that from like, what was it, like junior high or maybe upper elementary? If you had like 2/3 divided by 5 over 6, that's the same thing saying 2/3 times 6 over 5. Y'all remember doing that? You get it. Reciprocal y. We don't mess with y, you just do it. Right? Okay, well hopefully the pre-cal, my goal is at this level of math, you're kind of understanding the y. Now I'm not even going to try to tell you how the y on this one. I'll tell you how the y on the unit circle. But y you can multiply by the that's some complex arithmetic there that we'll get into. But here we've got no problem. 1/2, those 2's will cancel out, and so we have 1 over root 3. But we don't really like 1 over root 3. We're going to multiply that by root 3 over root 3. So root 3 over 3. Let's verify that. That's okay. So ladies, y'all type in tangent pi over 6, hit enter. Guys, root 3 over 3, enter. We're gonna see if we get the same. Ladies, you probably get your answer first because you're a little faster. Go fast, guys. They are. I'm sorry. You know, someone at some point says, guys are good at math. Well, that's a nice thought. But in my experience, normally, at least in my classes, I probably do the numbers sometimes, but ladies normally pick up on. I don't know. Maybe they just listen better. So I see those head nods. Ladies, what do y'all have? Tangent pi over 6. You said 1 point what? 1.57? Oh, there's no 1, it's just 0.7?
0.57.
I can't listen. See, I can't. 0.577. Alright, guys, did we get the same?
Yep.
Yes. 0.577? Okay. Well, I am included in that statement there. Okay, so verified, great, it works. You might want to write that on your notes. That root 3 over 3 is actually a very common number. It's not as common as root 3 over 2, but it kind of helps to have that one knowledgeable. The neat thing is that the tangent over here should be about the same thing. Let's try this one. Let's do, since we're doing tangents, tangent 5 pi over 6 is y over x, right? So here's 5 pi over 6. Call out to me, class. What's the y value on 5 pi over 6? 1/2. What's the x value? Negative root 3 over 2. How does that compare with our other one? It's the same thing, except this one's negative. So I would assume that this one I can say is negative root 3 over 3. You know what would be kind of a fun activity? Let's go ahead and do this, okay? Which other ones would have, so I'm gonna write a little thing off to the side here on my unit circle. I'm gonna write tangent. Because I've got the x and I've got the y. I want something that I can look here real quick and just quickly find out what the tangent is, right? So the tangent right here was root 3 over 3. For this one over here, tangent was negative root 3 over 3. What about this one down here? This is that same 30 reference angle. Tangent, it's y over x. The y is negative 1/2, the x is negative root 3 over 2. The only difference there is they're both negative. So negative over negative is going to be a positive, so root 3 over 3. And then over here, my tangent also is going to be root 3 over 3. There we go. We've done it now once, so we never have to do it again. I kind of like that, assuming you keep that chart there. Let's do it for this one right here, so might as well just get it out of the way right now. So, what's the tangent of pi over 3?
Root 3.
So call out to me, class. Tangent is what over what? Y over x. So what's the y value? Root 3 over 2. The x value? 1/2. So I'm going to do my fraction math. The numerator, root 3 over 2, times reciprocal of the denominator, 2 over 1. This one was easy. 2's can't. It's just root 3. Okay. So I'm going to write the little tangent thing here. Tangent theta root 3. What's going to be the difference between the tangent of pi over 3 and the tangent of 2 pi over 3? Why is it negative? Well, not, yeah, it's still, it's just root 3 over 2 divided by negative 1/2. So I'll put t for tangent, I'll write t for tangent. Negative root 3. Ooh, what's that decimal approximation, just in case I ever see it?
And it's 1.7320.
There's your 1.7. Down here, tangent. It's negative over negative.
Yep.
Positive. Over here, negative over positive. That's gonna be negative. And it's negative 3. Never have to do this again.
Hold on.
Wait, would that one tan root 3 over 3 for the, would that one be positive above the,
This one right here?
No, it's negative.
No, it
That would
wouldn't.
be negative.
Good catch. Yeah. That one was positive, this one was negative. Yeah, yep. You know, every year I talk about doing what we just did with my classes, but then we never do it. But good, we did it now, and so now you can just have that as a reference, and you've got Mr. Greensword, nah, never mind, we'll just don't worry about it. I'll just pull it up here. Y'all have your, where's that paper that y'all have?
This one.
Circle Tree 2?
Oh, out of the student circle.
Number 1. Does it say, find the terminal point on the unit circle determined by 5 pi over 6 radians? Okay, we don't need Mr. I go right here, so we'll just, 5 pi over 6, is that one labeled here? 5 pi over 6, there it is. They're looking for the terminal point. That's this guy right here. They just want that coordinate. Number 1, the terminal point on the unit circle determined by 5 pi over 6 radians is negative the square root of 3 over 2 1/2. That's the answer number 1. Question 2. Find the terminal point on the unit circle determined by 7 pi over 4 radians. Oh, we're going to have to go back to that other one. So 7 pi over 4, that's the pi over 4 one. And somebody tell me, what's that coordinate right there? Good. Question number 3? Who cares? We don't have time. Alright? On Monday, we'll go over some of these other problems, which will literally take us maybe 10 seconds each. Cosine, sine, cosine. We're just going to look at that unit circle. It's going to be awesome. And we're moving on to the next one.
Oh, we did that, but you can't. Yeah.
Today we talked about the unit circle. You're going to love it.